Big Bench, a unified benchmark for social bias in text-to-image generative models based on multimodal LLM. Abstract. This paper introduces VersusDebias, a novel and universal debiasing framework for text-to-image (T2I) models. It addresses the issue of social bias in human image generation against demographic groups, particularly women and colored races. The framework consists of one generative adversarial mechanism, GAM, and one debiasing generation mechanism using a small language model, SLM. The self-adaptive GAM generates specialized attribute arrays for each prompts for diminishing the influence of hallucinations from T2I models. The SLM uses prompt engineering to generate debiased prompts for the T2I model, providing zero-shot debiasing ability and custom optimization for different models. Introduction. Text-to-image, T2I, models are evolving at an extraordinary speed due to the low barriers to entry and open-source initiatives by companies such as Stability AI. However, similar to other generative models, the growing adoption also raised concerns about fairness and biases in generated images, especially in images depicting human. Some research shows that the models have obvious biases to specific social groups, especially women and colored races. Methodology. To address this, we propose VersusDebias, a universal zero-shot debiasing framework for T2I models, consisting of a generative adversarial mechanism, GAM, and a debiasing generation mechanism, DGM. A simple workflow is shown in Figure 1. Similar to generative adversarial networks, GAN, our GAM consists of a generator and a discriminator. This component does not directly participate in the final image generation but provides a dataset for the executor to modify the prompts. Through adversarial generation, GAM produces debiased attribute arrays corresponding to 2060 prompts, which consist of protected attributes from the ignored social groups. The main body of our DGM is an fine-tuned small language model, SLM, which ensures performance while significantly reducing computational resource consumption compared to traditional LLMs. The SLM can accurately identify potentially biased attributes in complex prompts and contextually add protected attributes according to debiased attribute arrays to generate debiased prompts, providing zero-shot debiasing capability. Since the generator in GAM and the T2I model used in DGM are the same, debiased attribute arrays can mitigate the hallucinations of the T2I model through post-processing. All models in VersusDebias can adapt to a new model through inference alone without retraining, which circumvents the computational overhead. Additionally, VersusDebias is designed as a universal plugin module, equipped with interfaces based on Comfy UI API and WebSocket. This allows it to adapt to thousands of models compatible with Comfy UI simply by replacing the workflow file. This structure, combined with the adaptive capabilities provided by GAM, enables VersusDebias to reduce biases in any T2I model. Evaluation. To evaluate the effectiveness of our work, we compare VersusDebias with other methods from two perspectives. First, we evaluate the demographic bias of 3 standard models before and after incorporating VersusDebias. Second, we compare VersusDebias with existing debiasing methods. All comparisons are conducted using both small-scale human evaluations and large-scale machine evaluations based on multimodal large language model, MLLM, considering both zero-shot and few-shot scenarios. The results demonstrate that VersusDebias effectively reduces biases in T2I models and significantly outperforms other methods. Related works. Biases in T2I models. Over the last few years, T2I models like Stable Diffusion and DALL-E have seen increasing adoption. Many T2I models can generate high-quality images efficiently. Nonetheless, several studies prove that these models inherit biases from their training datasets. Recent research classifies these biases into implicit generative bias and explicit generative bias, corresponding to the sociological concepts of implicit bias and explicit bias. Implicit generative bias refers to the phenomenon where, without specific instructions on protected attributes, T2I models tend to generate images that do not consist of demographic realities. Explicit generative bias is a specific type of hallucination, referring to the phenomenon where T2I models tend to generate images that do not consist with prompts containing specific protected attributes. In our work, we primarily address the issue of implicit generative bias and avoid the influence of explicit generative bias, which disturbs conventional methods. Here is a combined summary of pages 3 and 4 of the research paper. The proposed framework, VersusDebias, addresses the issue of bias in text-to-image (T2I) models by leveraging the advancements in multimodal language learning models (MLLMs) and small language models (SLMs). The pipeline of VersusDebias consists of a generator, a discriminator, and a dataset. The discriminator employs a MLLM to perform zero-shot semantic alignment on generated images, extracting information on gender, race, and age. The alignment results are statistically averaged to determine the generative demographic proportions of 3 protected attributes for each main prompt. The discriminator then compares the proportions of each gender, race, and age group to the ground truth and modifies the prompts by adding underrepresented protected attributes. The generator uses the fine-tuned SLM to accurately extract the potentially bias-inducing main prompt from the user prompt and adds an appropriate protected attribute based on the best results. The generator then uses the processed prompt to generate debiased images. The framework is compatible with various T2I models, including diffusion-based and transformer-based models, and uses Comfy UI as the tool to connect VersusDebias with T2I models. The dataset creation process involves consolidating occupations from the Bureau of Labor Statistics, adding descriptions of image quality and character states, and generating 20 prompts for each occupation. The discriminator consists of 3 components: the aligner, the array editor, and the evaluator. The aligner extracts information about individuals in the images and computes the average of the extraction results. The array editor compares the generative proportions to the ground truth and adds underrepresented protected attributes to the prompt. The evaluator provides a comprehensive metric for evaluating the overlap between the generated results and the ground truth. The array editing algorithm is presented, which generates a new dictionary by subtracting the ground truth values from the actual generative proportions. The keys in this dictionary are main prompts, with negative values indicating underrepresentation. The array editor adds these underrepresented attributes to the attribute array and performs this operation once per epoch until the specified limit is reached. The evaluator uses cosine similarity to determine the similarity between the generated results and the ground truth, treating gender, race, and age as vectors. The paper discusses the development of VersusDebias, a novel debiasing technique for text-to-image (T2I) models. It focuses on improving the accuracy and fairness of T2I models by addressing gender, race, and age biases. The technique involves weighting these biases and using a specialized dataset to fine-tune the model. The authors present comparative experiments with several state-of-the-art SLMs and LLMs, showcasing the performance of VersusDebias in both few-shot and zero-shot scenarios. The results demonstrate significant improvements in debiasing, especially in race and age, with the model achieving higher accuracy and fairness. The technique's effectiveness is further highlighted by its ability to improve the performance of a model that initially performed poorly. The authors also investigate the impact of the attribute array length, showing that increasing the length leads to smoother variations in demographic proportions, further enhancing accuracy. Overall, the paper contributes significantly to the field of debiasing in T2I models, offering a promising solution for improving the fairness and accuracy of these models. The research paper introduces VersusDebias, a universal debiasing framework for text-to-image (T2I) models. It enables precise and efficient debiasing for any T2I models by prompt engineering. The framework consists of a novel generative adversarial model, GAM, to generate corresponding debiased attribute arrays and an advanced SLM for editing prompts. Extensive experiments validate that VersusDebias surpasses existing methods in both zero-shot and prelearned situations, maintaining the original model's image generation style and quality. The paper also discusses limitations and future work, highlighting the need for better model classification and handling extreme cases of hallucinations. The pages discuss various aspects of text-to-image generative models, focusing on multimodal LLMs and latent consistency models. They highlight the importance of fairness and bias mitigation in these models, referencing studies on implicit bias and social biases in grounded vision and language embeddings. The summaries also touch on the efficiency and effectiveness of diffusion models, including adversarial diffusion distillation and safe latent diffusion. Furthermore, they emphasize the need for fair human generation and mitigation strategies in text-to-image models. The content also includes discussions on the limitations and future work in this field, such as the importance of transparency and accountability in AI development.